Hi, my name's Tony Liechty. I work for National Instruments. I've worked here for about 4 years. I studied electrical engineering at Purdue University, and I have a 4-year bachelor degree from there. So yeah, here at National Instruments, I'm an electrical engineer. I design circuit boards that are used in robotic type applications. So this product right here is one of these electronic circuits that I designed. The customer will use this to control robotic circuitry. And one thing that this product specifically is used for is to control the launching of missiles off to an island off of the coast of the US. So the government will test that missile to make sure that it can hit a piece of paper. It's a piece of paper about this big essentially. And the missile has to hit that every single month, every single time without mistake at all. So they will use my product to make sure that the missile works properly. So they'll hook up my product to the missile and test the missile to make sure that it will hit the target every single time. It's a very dangerous thing. If my product doesn't test it properly, then the missile will fly off course and hit something that you don't want it to. So yeah, it could go and hit someone's house or go hit off and hit someone's country by accident, which is not a very pretty thing at all. So I was told that a professor was introducing you to different electronic concepts. She introduced to you a light bulb and a switch, and how to hook up the light bulb and switch into a circuit to turn on the light bulb. And she introduced different ways of making the light bulbs the same brightness, or make it a dimmer brightness, or to turn off the light bulb on and off with an electronic switch. Now each of those components you can draw on a whiteboard in a different way. When you draw electrical components on a piece of paper, it's called a schematic or a circuit. And I'll give you an example of how to draw each of these components. So the first component that she introduced was a battery. If you look at a battery, it has two ends to the battery. You have one end marked with a plus symbol, and then one end many times is marked with a minus symbol. And the way that you draw a battery on the board is you draw a circle. At the top of the circle, you put a plus symbol to represent the positive side of the battery, and at the bottom end, you put a negative symbol to represent the negative end of the battery. And when you draw the battery on the circuit, you take two wires off the ends of the battery in order for you to connect them to whatever you would like to connect them to. The other component that the professor introduced to you all was a light bulb. This is one example light bulb. It's a little bit smaller than the one she had, probably a little bit dimmer than hers also. This also has two terminals to it, and when you hook it up to a battery, it turns on. So the way that you would draw that in a circuit diagram is by taking the wire and then drawing the component for the light bulb. And when you draw a light bulb, you usually draw two arrows indicating that this component will produce light whenever current goes through it. So that's the symbol for a light bulb. So that's how you draw a light bulb in a circuit. One other thing she did in her diagram was put two light bulbs in series with each other, like this. And if you remember from when she did this experiment with the battery and the light bulbs, you notice that the two light bulbs in series with each other were dimmer than when you just had one light bulb in the circuit. And the reason why is that the electricity has a harder time flowing through this circuit diagram because there's two components to flow through instead of just one component, making the light bulbs dimmer. Another way that you can make the light bulb dimmer is by using another component called a resistor. Now, a light bulb is essentially a resistor that produces light. It makes it harder. A light bulb makes it harder for electricity to flow through the circuit diagram, and a resistor does the exact same thing. So I'll show you an example of how you can use a resistor in a circuit in a little bit here. So here's an example of a resistor. It's a lot smaller than a light bulb is, and it also costs a lot less than a light bulb. So both a light bulb and a resistor both have resistance with it. The only difference is that a light bulb will emit light and a resistor will just resist the flow of electricity. So one way you might use this in the circuit diagram is, say for instance, you only want one light bulb to shine, but you don't want it to be as bright as just hooking it up to the battery directly. What you would do is replace this light bulb with a resistor component instead. So what this circuit will do is you have two components in series, which makes it harder for the current to flow through this circuit, which then makes this light a lot dimmer than what it is now. So we replace the light bulb, which is also a resistor, with a resistor which does not emit light into the world. And this is one way to get the light bulb dimmer without using two light bulbs. Right, so as I mentioned, I'm an engineer. There's also physicists in this world. The difference between an engineer and a physicist is that an engineer will use the concepts that physicists come up with to actually design and create things according to customer specifications. So I heard that you all are coming up with a project where you need to have 3 light bulbs in your circuit. You need to either make those 3 light bulbs the same brightness or make those 3 light bulbs different brightnesses based on whether you turn a switch on or off. So I'll give you an example of how you can draw this in a circuit diagram, how you can cause each of those 3 light bulbs to be the same brightness in different circuit configurations. So I'll replace the light bulb in the resistor and replace it with 3 light bulbs, and I'll draw it first and then explain what the circuit's doing after that. So one way you would make the 3 light bulbs the same brightness is by putting them all in parallel. Because these are the exact same light bulb and they all have the same resistance, the current will come out of the battery and then it'll come off to a teeing point. Because all these are the same resistance, the current will just split 3 equal ways and go through all 3 of these the same amount, making them all the same brightness. And say for instance for your project you need to turn the light bulbs on and off. I'll show you how to draw a switch, just since when you guys use your project you'll have to know how to draw a switch also. The way that you draw a switch is by making a break in the line, and then you just draw a straight line up, put a dot at the bottom here and a dot at a bottom over at this corner right here. And this is a picture of the switch opened, and to close the switch you just draw the line straight across like this. So in this example, since the switch is closed, all 3 light bulbs will be on at the same brightness. But if you take the switch and draw it up like this, then it will cause all the light bulbs to be off because the current can no longer flow through the light bulb since you broke the circuit in half. So another way to make all of the light bulbs the same brightness is to put the 3 light bulbs in series rather than in parallel. And the way you would draw this is just like so. Put an arrow to indicate that it emits light into the world. And in this diagram, when you close the circuit, the current will flow out of the battery and flow through each of the light bulbs the same amount. The same current that flows through this light bulb will also flow through this light bulb and will also flow through this light bulb. There's only one path for it to flow. In this example, the lights will be dimmer because you have 3 resistances in series with each other, which makes it harder for the current to flow through the circuit. In the other case, you had them in parallel, and it didn't have to go through one, then the other, slowing it down each time. It went to all of them in parallel, and it only had to go through one in order to reach the end of the battery again. So that's the second way of making all 3 light bulbs the same resistance. I'll show you a third way of doing this, which is maybe not as intuitive, but could be important for the project that you guys are using. So a third way to make the light bulbs all the same resistance is I'll draw it again and then explain it after I draw it. Again, you start with 2 light bulbs And so what I drew here, I'll draw my resistor a little bit better here. Kind of looks like a light bulb. So in this circuit, I have 4 components. I have 3 light bulb components, which produce light, and 1 resistor component. Now, if you remember, the light bulbs also have a resistance, just like the resistor does. The only difference is that it emits light into the world. So to illustrate how each of these 3 light bulbs are the same brightness, I'll break the circuit up into two separate subcomponents. From the previous example, you know that if you connect the wire over to the negative end of the battery, you have both of these light bulbs in parallel, and the current will go and split and make the brightness exactly the same. Now in the bottom case, you have a resistor in parallel with a light bulb, and what we do is choose a resistor, the same resistance as the light bulb itself, to cause the current to split equally between the two. And in this case, if this was a light bulb, both of these would be the same brightness. But since you have a resistor and a light bulb, you only have one shining. And it would be the same brightness as if you had another light bulb there, except you just have one shining instead. Now, if we combine those 2 circuits together and redraw it to the complete diagram, putting them both into the circuit, you'll have 3 light bulbs of the same brightness. And the reason why is that current will come out of the battery, it'll split equally between these 2 light bulbs, and you'll get half the current through this one and half the current through this one, making them the exact same brightness. And then the current will combine back to the center into one wire again, and then when it comes through this wire, it'll split again. Half of it will go through this resistor and half of it will go through this light bulb. So then you get half the current here and half the current here. And because in both this top case and the bottom case, you have half the current that goes through this one and half the current that goes through here, and down at the bottom you have half the current that goes through this light bulb and half the current that goes through this resistor. Since all of them get half the current, then all 3 of these light bulbs are the exact same brightness. So this circuit right here is another example of how to make 3 light bulbs the same brightness. Good luck designing your circuits.